Well, good morning, everyone. Oh, thank you. I want to thank you guys so much for coming out to PDC, wonderful sunny Los Angeles. I hope you guys are having a great time. I know there are so many sessions here that there are probably more that you want to go to than you actually can. And for that, I truly thank you for coming to spend the time with me to hear about my little slice of Windows 7. I'm really honored to be here today on behalf of the entire engineering team working on the sensor and location platform, to be the first person to really unveil what we've been working so hard on for the past 2 years. But before we get started, I just want to run through a couple ground rules. Number one, I would appreciate it if we could hold questions until the end. There are 2 microphones in the aisles, and I will be leaving time to take questions. If we're not able to get through everything here, or if you're not comfortable coming up to the microphone, I will be available for the rest of the week, either right after my session outside, or out in the big room at the Windows 7 booth, the track lounge, at Ask the Experts this evening. In short, I'm here, so if you have any questions, please come find me. I'm very happy to answer them for you. Number 2, evaluations. I truly appreciate it when you fill out your evaluations. I want to make sure that I'm doing as good a job I can to make sure that you're getting value for your money when you come to conferences like PDC. So please do take the time to go fill out the evaluation afterwards and let me know how I did today. So I want to get started by introducing myself. My name is Dan Polivy, and I'm a lead program manager in the PC3 division at Microsoft. So I live in Seattle, and there are a couple of things that Los Angeles has that Seattle doesn't. Number 1, sun. It's that time of year where I probably won't see it again until June. Sad but true. And here I am, 80, 90 degrees every day in Los Angeles, stuck inside in a nice dark room like this. Second thing that Los Angeles has that Seattle doesn't, In-N-Out Burger. Everybody loves a good double animal style every now and again, right? All right. Now you may ask why I'm telling you this. So let me tell you a little story. I got here a couple days ago, and before PDC got started, I wanted to go get some sun and get some In-N-Out Burger. But I'm here on a business trip. And as you all know, just because you're not in the office, the email doesn't stop. In fact, I think it doubles once you leave. So I figured I'd take my laptop down to the beach, catch up on some email, and get some sun while I'm at it. You're probably familiar with what happens here. You get down to the beach, it's really sunny outside, you find a nice spot to sit, you open up your laptop, and then, gee, I can't see anything. How am I going to get my work done? I either have to sit in the sun and not do my work, sounds nice, or do my work and sit in the shade so I can actually see or go inside. Being the good corporate citizen that I am, I went in the shade and did some work, but we won't talk about that. But wouldn't it be great if my computer knew where I was? If my computer knew that it was really sunny outside and that there was a lot of glare on my display? How would it react? What if it could automatically adjust the way that it behaved? And if my applications could adjust so that I could read them in the sun even in those adverse lighting conditions? That tiny font that Outlook uses, what if it could get a lot larger so I could actually see something? Something to ponder. In fact, I'll advance my slides. So that's only part of the story. So I finished up my email, and then I was hungry. Now, I'm not from Los Angeles, so I have no idea where I am. And I want to find the nearest In-N-Out Burger. So how do I do that? I have to first figure out where I am, then go type that in and do a nearby location search to find the nearest In-N-Out Burger. But why is that so complicated? My computer can figure out where I am. There's a lot of technology out there that can tell it where I am right now. Why can't it use that knowledge to automatically tell me where the nearest In-N-Out Burger is? Or as a developer, why can't my applications take advantage of the knowledge of where I currently am to make the content more locally relevant? So I'm very honored to be here today to tell you how you can solve these problems and how you can make your applications more contextually aware with Windows 7. So here's my agenda. I hope I got you hooked now, so you're going to actually stay for the whole thing. I'm going to talk a little bit about the different components we have and the different pieces that we've built into the operating system to make this possible. Talk a little bit about the overall sensor platform and the overall location platform. And then we're just going to dive right into location. Talk about how you can make your applications location aware very easily. And once we figure out where the nearest In-N-Out burger is, then we're actually going to go look at how we can solve that light problem. How can I take advantage of a light sensor to know what the ambient lighting conditions currently are, and then do things in my application to react to that? Now, because a lot of this is hardware-based, I'm going to talk about our sensor development kit. Those of you who have already been down to the big hall to visit us may see that we're giving away some cool goodies, and I'll talk about these later. But I want to tell you exactly what this is and how you can use it to your advantage to get started with the pre-beta bits that you're getting here at PDC. But before we get to all that, I want to show you some new features, right? It's always good to start off a demo with some new features in the operating system. So this is my PC. Now, this is the same build that you'll have access to on the hard drives you're getting at PDC, build 6801. And I did not turn off my notifications. So I have in here a virtual GPS device, and it's playing back a road trip from Seattle to Boston. So I grew up in Boston, which is the other end of I-90. Seattle is the west coast end of I-90. So I've lived at both ends of I-90. And I've played back a trip, or I've recorded a trip going from one end to the other. Now, I do that because having a location demo when you're not moving is really not very interesting. I could do it and tell you it's real, but maybe you wouldn't believe me. So first thing I want to show you, this is a feature in Windows 7. It's the weather gadget. You're probably all very familiar with the weather gadget from Windows Vista. And you boot up your brand new Vista PC, and it shows you the weather for Redmond, Washington. 90% of the time, if it's not July or August, it's going to be cloudy. Great. But then you have to go in and change it yourself. Well, Windows 7, as I said, is location aware. And as part of that, the weather gadget is location aware. So what it's doing right here in automatic mode is updating to show me the weather of my current location. Now I'm going to drag another gadget onto the desktop. This gadget is our location sample. It's actually part of the Windows SDK. So you also have access to the code for this. And what we do here is host a virtual earth control. It's getting a little sticky. We host a virtual earth map control in a JScript gadget. And as we go across our cross-country trip, the push pin is updated to my current location. And you can see correspondingly the get weather gadget is updating to the weather for the location where the push pin is. So this is all live running Windows code today. The only thing that I've tweaked is the weather gadget. It's been slightly modified for demo purposes, but I do assure you that in Windows 7 it is location enabled. So here we go. I'm going to show you how we did this. But before I get into that, I want to tell you why we did this. Because you may say, Dan, okay, this is all very interesting, but I can do this today. I can build a location-aware application. I've got a GPS puck. Yeah, for those of you that have actually tried to use it, you may be familiar with the 80s era standards that are commonly used, such as NMEA and serial ports. And you may wish that you didn't have to learn about these. For those of you that are not familiar with how location is done today, you're much better off. So if you want to use a GPS device today, right, it's a USB device or however it connects to your PC, but it's a COM port, right? COM 5, COM 6, COM 7. It's a different one every time you plug it in. Not only that, but it's exclusive. So the first application that opens that COM port is the only application that can be location aware, which is good if you only have one location aware application you want to use. But if, say, your weather gadget locks that port and you can't use your mapping application, that's kind of a shame. So assuming that's okay with you, and assuming that you don't care that anybody can just go ahead and open that COM port on your machine, then you have to go license the data formats. And you have to realize that every device uses a slightly different version of NMEA. So they have their own proprietary sentences, because some have 5 satellites that they include, some have less, some have more, some have additional data that they put in. It's really quite complicated. And there's not a lot of interoperability between different devices and different software applications. And if there is, you have to do all that work manually. So okay, so assuming you use GPS today, that's great. What happens when you go indoors? In this building here, pretty sure I'm not going to get a GPS signal. In fact, I can almost guarantee it. But I may be able to triangulate my location through Wi-Fi hotspots, maybe use cell tower triangulation, There are other technologies that can give me an approximate location almost as good as what I can get with GPS. But you know what? If you want to do this today, then you have to write a different provider, a different set of code to talk to each different location source. And it's really complicated. It adds up after a while. So looking at sensors in general, they're primarily sold as vertical solutions today. So let me give you an example. You go into the store, you want to buy a GPS puck. Right? You can buy a navigation device, which is a little self-contained navigation device. When you plug it into the PC, you can do firmware updates and copy your music, but that's really about all. Or you can go buy software like Streets and Trips. But really what people do is they go to the store and they buy Streets and Trips with a GPS puck. It comes in one box now. Most software solutions, most sensor solutions are like that. It all comes together. If you look at a laptop PC, laptop manufacturers that include light sensors or accelerometers, they're all closed systems. There's no access to those as developers to go in and take advantage of them in your applications. So that's the problem that we wanted to solve. We said, hey, there's a lot of good stuff that's happening with sensors being incorporated into PCs and a lot of really cool things that you can do with them when they're in there. So let's make it really easy for developers to go ahead and access these. So I do present to you the Windows Sensor and Location Platform. So this is really two separate platforms that are built on top of each other. And our goal here is to provide a standard unified driver model for all types of sensor devices. So that could be physical devices, things like GPS pucks, wireless WAN data cards, accelerometers, light sensors, human presence detection. Any kind of physical sensor, you plug it in and it enumerates a driver in Windows. That's supported by our platform. But what's also supported are logical sensors. So logical sensors are things like Wi-Fi triangulation. There's no Wi-Fi triangulation device that you go buy and plug into your PC. It uses your existing Wi-Fi card and typically a web service, and it sends data back and forth. So there's some back-end database. We call those logical sensors, and we support those as well. Now, in addition to providing a standard driver model, we also provide a standard set of APIs. Being good Windows citizens, they are C++COM native APIs. I realize that alienates probably 80% of you in the room, but please don't leave. I've got a lot of stuff for you later in the presentation. So just because our APIs are native C++COM, they are accessible from managed languages, and I'll show you how we're going to do that later. So we have two API sets. We have the Sensor API set. Sensor API is really about access to individual raw sensors. So with the Sensor API, I can enumerate the light sensors, the accelerometers, the GPS devices, and talk with the device directly in a very standard language. The Location API, on the other hand, is really a domain-specific API optimized for the location scenario. So as a developer, when I want to know where I am, I don't want to have to open and enumerate every single location device and figure out which one to choose. I just want to ask a question, where am I? And I want Windows to tell me the answer. That's exactly what we've done with the Location API. But in addition to that, we've added a layer of security. We're trying to raise the bar because location is considered PII. That's personally identifiable information. Right? Where I go and what I do, when I go to the beach to work, when I'm in PDC, that's my business. I don't want my IT admins to track me. So I want to be in control of disclosure. And our platform allows for that. We have an opt-in security model, and I'll show this to you in a little bit. So all sensors have to be turned on before they can provide data to applications. So let's get into some architecture. I'm going to start at the very bottom here with our sensor device. So typically you'll have a device, whether it's, again, a physical device or a logical device, and that comes with a corresponding driver stack. Now, we are using the user mode driver stack, which means it's very easy to go build drivers, to debug drivers, and generally to write them. You don't have to have two machines to do kernel debugging and worry about blue screens. It's much, much easier to go write a user mode driver. Now, within the user mode driver, we actually give you a component we call the sensor class extension. Sensor class extension handles the bulk of the communication to the upper layers of the platform and abstracts out a very simple COM interface that a driver developer can implement that allows them to expose which sensors they have on their hardware, as well as the properties that that sensor supports, and as well as all the different data fields that are associated with that. There are events and other things. I'll talk about those later. Now, one thing I will note, you can have multiple sensors in a single device. So, for example, you could have a light sensor, an accelerometer, and some touch sensors all in a single device with a single driver, but they get exposed individually up to the application. So I mentioned on the last slide that we have access control. So the user's in charge of which sensors are enabled and when. This is done through our location and other sensors control panel. If any of you have installed the Windows 7 build already and poked around in the control panel, you might have come across this. It probably was empty. But once you have sensors in there, you can actually go, and they're all shown, and you can enable them for everybody on the system or individually for different users. And this is all built into the platform. So again, as an application developer or a driver developer, you don't have to worry about access control. We make it very easy. And then on top here, we have the API. So the API interfaces with our control panel, interfaces with the drivers, all the different sensor devices, and allows the applications to go and enumerate, to query, and get data from all these different devices. Now, I said location API was built on top of the sensor API. And that is true here. So in this diagram, location API, we have a COM API, which is iDispatch compatible. Those are built on top of our sensor API. And those allow us to talk to all location sensors included in the PC. And now we can access these from gadgets or scriptable applications or any native or managed code as well. Sorry. So, what's so nice about the location API? Well, the first benefit here is that it's really easy to answer the question, where am I? This is the thing that you need to know when you're writing a location-aware application. Where am I? What's my latitude, longitude? All right, that's all you need to know. You don't care about any of the other details. Location API abstracts this out, so you don't have to worry about the details of the specific provider. So you say, I want to know my latitude, longitude, and the application, the API, takes care of the rest. You can do this in a synchronous fashion. So you can say, give me the current location as you know it. Or you can say, tell me when that location changes. Register for events. And every time the location changes, we'll let you know. The latter one is much better for performance. All right, so you can power optimize when the sensors are actually providing data by doing it asynchronously. So it's all interrupt driven, as opposed to polling constantly and having to keep a sensor alive when the location may not have changed very much. In addition to surfacing or abstracting out the different sensors, we provide automatic transitions. So here's a scenario. I have a GPS in my laptop over here. I'm outdoors, it's working fine. Then I decide to come inside, come into this conference room. I lose my GPS connectivity, but I still have a Wi-Fi triangulation driver installed. So the location API is able to seamlessly transition over to that Wi-Fi resolver and surface the latitude, longitude from that in the same way that the GPS data was surfaced. So there's no difference from an application perspective. It's all the same. Now, we also saw the problems of concurrency. So earlier when I talked about virtual COM ports and how the first person that opens it wins, with our platform, you can have as many applications using the API at one time as you want. It's all available to any application as long as their permissions are enabled. Now, finally, we realized that the majority of machines, maybe 50% of machines today, are not likely to have any location hardware. Desktops, for example, not likely they're going to be moving anywhere very often, and not likely you're going to go buy a GPS puck to plug in. So we have a notion we call default location. If you go in the control panel on Windows 7, you'll find a default location control panel that allows you to enter your location manually. So I can go in and type in as much or as little of my address as I want, my country, my zip code, my city, my state, my address, my street address. And you can also enter your latitude, longitude. And we've actually got APIs to extend this so that computer manufacturers and third parties can go and build their own default location providers. Let me give you an example. So that map I showed you earlier, that location map where it just showed you where you were, what if I could click on that and say, I am here? Well, you could use the default location APIs to do that. It's really meant to say, okay, here's my default location, and for lack of a more accurate sensor. And then that will get stored into the registry, and it's exposed through the same API set. So again, seamless transitions across all the different providers, from those that are manually entered to those that are automatically determined through a sensor. So here's what the API looks like. This is our COM version. Our main interface is iLocation. So iLocation has two primary methods that you'd use. The first is called register for report. So register for report is the asynchronous way that you figure out where you are. You say, call me back on this events interface when my location's changed. And you say what kind of location data you're interested in. I'll talk about that in just a sec. There are different kinds, or two different kinds of location data. And you can also say, I only care about location that changes every second, every minute, every hour, every 6 hours. You can specify an interval that says, I really only need to update this once a day. The benefit here is that the device can now optimize itself. So if it knows that you're only going to get data once a day, it may only turn itself on once a day. Versus if you need data once a second, it may want to keep itself active all the time. Again, on a laptop where battery power is a constraint, you want to be as energy efficient as possible. Second method here, get report. This is our synchronous API. So you say, give me my current location, and we give you back a location report object. As far as the location events interface goes, again, it's fairly straightforward. When the location changes, you'll get the on-location change callback with the appropriate report interface. And from the report interface, you can go and query the latitude, the longitude, the altitude, and the other associated data. So there are two main report types that we support. The first refers to geographic data. We typically call that latitude and longitude. In fact, in our code, that's the iLatLong report. So in the lat-long report, the minimum required fields are latitude, longitude, altitude, and error. So you want to know how big your error radius is so you can know how much to trust that data. But we also support additional properties. So for devices like GPS, where they may want to tell you how many satellites they're currently locked into, or the last ephemeris data that they used in order to get that satellite fix, that information is also exposed through an extensibility interface in the API. Now, the geographic data is the most common source of location, or most common type of location data used today. It's also the most flexible. It works well for precise location when you use it on maps. And it's very easy to go and translate this into a physical address using a reverse geocode solution. There are a lot of web services that provide this functionality. Second type of location we support is a civic address. So civic address or postal address, this is pretty much a street address, city, state, zip code, country. And this is really valuable data as well. Imagine for the majority of web applications where all you need to know is your zip code in order to provide locally relevant information. You may want to just get that zip code directly as opposed to having to get a latitude, longitude, and then do some translation on that. So this is really good for humans to read compared to a lat-long. But it's not going to be the most common support, not going to be the most commonly supported data format. So GPS devices aren't natively going to provide civic address data. Excuse me. So here's what our interfaces look like. The iLatLong report supports the properties that I mentioned before. They're all doubles. And the civic address report, again, exposes each field individually as strings. So enough about the COM stuff. I think it's time to get into some JScript. Do we have any JScript developers in the audience? A couple? OK. That works. My gadget's still running. So what I'm going to do is actually show you the code behind this gadget. Show you how easy it is to figure out where you currently are. Get this out of the way. And get this out of the way. So I'm going to open up my gadget folder. We're going to open this file in Visual Studio. So this is our gadget. First thing I want to point out is the lat-long factory object. So this is what we create that gives us access to the location API. There is a corresponding civic address factory as well, if you're more interested in getting that civic address location data. So we declare the object here. And then what we do is actually go ahead and initialize it. So I'm going to scroll back down to the gadget here, down to the reload map function. So in the reload map function, you can see first thing we do is figure out what's the status of my latitude longitude reports. Do I actually have any sensors available that I can query latitude longitude from? If I do, then I'm going to go, number one, listen for reports. So this is going to register my event sync to get the synchronous updates when my location changes. But I'm also going to currently get my current location so that I can have a good starting point. So if I scroll down here, I listen for reports. So you can see all we have to do here is register for events, and then we'll get called back on our lat long report factory callback object every time the location changes. And that's all the way back at the top. Ordered very well. So here's our event handler. So all we do here is we make sure we have a valid map, and we move the map to center it over our current location, and then move the pin. So you can see right here we have the latitude and longitude very easily exposed right through script. So you can do the same thing through interop with .NET. The dispatch API, it's very simple, very easy to use, and works across a number of different programming languages. So privacy and access control. I mentioned earlier that location data is considered PII. We call that personally identifiable information. And you know, there's a lot of discussion today in the media about applications that may expose users' personal information. There's a lot of concern about it. And so we want to make sure we're setting the bar high as a Windows platform so that users are aware of what's going on with information that may be flowing through their system. So point number one, all sensors are disabled by default. That means the user has to opt in to a sensor being enabled before you can access it in your applications. Point number two, you have to be an administrator in order to enable sensors. If we didn't have administrator requirements, then it really wouldn't make much sense to have an opt-in model, because anybody could just go and break through that. But we do allow per-user access control. So I'll show you the control panel in a sec. But the default solution is on-off for global for the system. We do have a way to drill down and say which users are able to go and get access individually. But here's what makes it really easy. So we have this thing we call the enable dialog. So this is where we expect most of the users to go, or most of the users to see, to be able to turn on their sensors. We don't really think that a lot of users are going to know to go to the location and other sensors control panel in order to turn these things on. So we've tried to make this very easy and seamless. So the idea is that you launch your application. It needs to use a sensor, and that sensor is currently disabled. There's a dialog that you can invoke that asks the user to turn it on. And this happens in line with your application. So it's part of your normal flow. If the user enables those sensors, then you can go ahead and access them immediately. If the user chooses not to enable them, then you don't have access, and they can go back to the control panel later to turn them on. So I'll show you what this looks like. Let me go back here to my gadgets. I'm going to put the map gadget back on. Let's zoom it out. There we are. Should be somewhere over here. Now I'm going to go to the control panel. So if I just type in sensor into the search box, location and other sensors comes right up top. So I can click on this. Here's our control panel. So I have two different devices plugged in right now. One is that virtual GPS giving me my cross-country path. The other one is for the little sensor dev kit, which I'm going to talk about later. So you can see my virtual GPS is enabled. So if I go here and I uncheck the box and hit apply, That sensor is now completely disabled. And the location applications I showed you earlier cannot get any location data. That sensor is locked down. If I want to go do this on a per user level, I can go change user settings, and then I can enable it individually for different users on the machine. So I'll enable it for my account here, but not system services or any other accounts. So if I hit OK, then you see it's enabled with limited access. So this is the main privacy controls that we have in the platform. And I will show you the enabled dialog in my next demo. All right. So I hope I showed you the tools that you need in order to make the in-and-out scenario happen, in order to help me find the nearest In-N-Out burger. I'm going to wrap up here with location and just say we've got a very convenient API that makes it so easy to get location data in your applications. We expose it through COM, through iDispatch, as well as interop. The main benefits here is that you don't have to worry about individual devices. You don't have to worry about GPS devices, wireless WAN, Wi-Fi resolvers. We take care of all that for you. As a developer, all you say is, I want my latitude, longitude, or I want my address, and then we'll give you the best known source of that data that we have. Finally, I want to just reemphasize the point that the user must consent to having their location data shared. Right? We want to make sure the user is aware of what's going on and where that data goes. And there's also a burden for application developers to inform the user when they're doing anything that may be touchy, maybe a touchy subject. For example, storing location, sending it off to the web somewhere. There is a burden, a collective burden that we must uphold in the industry in order to make sure users aren't scared of this functionality. Right? We want them to turn it on because it enables a lot of rich scenarios. But we have to make sure we do it in the right way. We don't want that information to be leaked. We don't want negative press. And we don't want people to be concerned or scared about what may happen when they check that box. So, now that I got my double-double animal style, let's work on light. So, this is what I saw when I opened up my laptop on the beach. Probably familiar to very many of you. A lot of glare on the display. It's kind of hard to make out the text. Colors kind of run together. Generally not really a great experience. But this is what we're forced to live with. This is the way things are today. So how can we fix this? Well, before I get into light sensors specifically, I want to talk about sensors as a general group. What they are, how we expose them in the platform, and how you use them. First thing you need to know. Sensors in our platform are assigned a category and a type. The way that I like to differentiate these is that the category tells you what is being sensed. So for example, a category could be location, could be light, orientation. So it's telling you kind of what kind of data you're actually going to get. A type is how you're going to get it. So when I think of type, I look at GPS. That's one way to get location data. IP resolver, another way to get location data. Triangulation, another way to get location data. For a light sensor, an ambient light sensor, a photocell, accelerometer, for orientation. So there are different types or multiple types that can map to a single category. So as a developer, you can choose, do you want to enumerate devices by category? Do you want to know all the location devices on the platform? Or do you want to know all the GPS devices in the platform? Now the thing that's really nice is that we've standardized the data formats for each of these. So say for light sensors, there's a standard set of data fields that you can access. So every light sensor will support at minimum these certain fields. So you're guaranteed to be able to get useful data from it regardless of what its type is. Similar things for location, orientation, and a bunch of other sensors. Now, the sensors, when you break it down, have four main components. There's metadata or properties. So these are things like, what's your current interval? Right? How often are you sampling the data? How often are you reporting that data up to applications? There's, for example, I completely lost my train of thought. In addition to current report interval, there's sampling rate. Could be power efficiency. Do you have assisted GPS, additional properties there that tweak how assisted GPS works, ephemeris data? There are all sorts of additional properties. Some of them are read-only, telling you information about how many satellites the sensor is locked onto, or when it last was able to acquire a fix. And then there are properties that are read-write. So things like the report interval or the sensitivity. I only want you to tell me when the data is changed if it's changed by more than 20%. So there are some properties you can set to configure how the sensor responds, and some that you can't. Data. This is the second piece of the puzzle. So we have what we call data fields. So there are data fields which are defined by property keys. And a property key contains the data field, so example, altitude. It contains the units, for example, meters. And it contains the type for the data. So for example, a double. So this is all implicit, or explicit, I should say, in the property key definition for every data field. And this is what makes it really portable and interoperable, because all these data fields are predefined. So every sensor that's a location sensor supports these property fields. So you know that you can query altitude in meters and get a double back from a sensor that's in the location category. Now we've also, we haven't limited it. So yes, we've defined a certain standard set, but this is all built on property keys and prop variants. And these are infinitely extensible. And in fact, the API, when you go look at it, allows you to query for any property key and get back any prop variant in return. So you can query for additional properties. So for example, if you know that this is a sensor made by company X and they support these extended data fields here, you can go and query those extended data fields through the same API set. So we enable differentiation for hardware partners, but we also make it very easy for application developers to get the core information they need without having to make it device specific. Now in addition to being able to get data fields, we have events. So a lot of events are data driven. For example, a particular data value has changed, may cause an event to fire. We also may have events when sensor state changes. So for example, the sensor goes from having a lock on a satellite to not having a lock on a satellite. Or it's currently in a power saving mode, or it's currently in a high power mode. So there are different events that can be fired that alert you to what the sensor is currently doing, as well as different properties that may change. So for example, if the change sensitivity or the sampling rate changes, you can get an event indicating that that's occurred, so you can adjust in your application. So let's dig into light sensors. What is an ambient light sensor? Well, it's a sensor that measures light intensity. So light intensity typically is using a value of lux, lumens per square meter. Nice and technical term here. So lux goes all the way from down to 0 in absolute pitch black environment, maybe 100 to 400 in normal indoor lighting conditions, all the way up to like 10,000, 40,000, a million in really bright sunlight, kind of a logarithmic scale. So I'll talk a little bit about how we manage that scale in a moment. But I want to say that light sensors are interesting to us for a couple of reasons. Number one, OEMs are starting to incorporate them into their PC products today. There are a few notebooks on the market that have integrated light sensors, although traditionally they're used for backlight control. Right? You want to brighten the backlight when you get into a very light environment and dim it when you get into a dark one, such as a keynote hall. That's easier on the eyes, and it's also good for your battery life. Now for Windows 7, another new feature we have is called adaptive brightness. Adaptive brightness is an implementation of this feature that controls your backlight automatically. So from a hardware vendor perspective, the only thing you need to do is integrate your light sensor through ACPI, which is a standard defined for the BIOS. Just do the hardware integration there, and we take over with the rest. We have a class driver inbox in Windows 7 for ACPI light sensors, and that combines with our adaptive brightness feature to automatically control your backlight. Now, in addition to that, because it's going through the sensor platform, that light sensor is accessible to you as a developer. So I can go use it in my applications to figure out what the current ambient lighting level is and respond accordingly. So there's a huge benefit here. We think that building light-aware applications, so applications that respond to changes in the ambient lighting environment, is really compelling from a user perspective. It makes it a lot easier for them to go and view their content wherever they are. For people that ride the bus a lot, you have glare coming in off the windows. It's far easier to go read newspaper articles, go through your email, if you can actually see what it is that's on the display. So I'm going to show you a quick demo of exactly what LightAware UI is. So let me go back and get rid of my control panel and my map gadget. So I have up here an ambient light sensor. It's integrated onto this little hardware board. And I'm going to put this face down on the desk so it simulates very dark. Now I'm going to launch the MSDN Reader application. So you may be familiar with the Reader SDK available on MSDN. This is for building really nice readers. This is just a sample here. It's not actually a live one. And what we've got is, there's a fly buzzing around. So we have our LightAware application here. And this is built on WPF. So I said that the rest of the 80% of you in the room that aren't C, C++ developers, here's my solution for you. This is a WPF application using an ambient light sensor live on Windows 7 on the pre-beta build that you get to take home today. So you'll notice that nothing's currently happening. Well, I didn't actually enable the sensor. So first thing I need to do is actually enable the sensor. And if this is working right, it's supposed to prompt me. Of course it's not. And in retrospect, I know why it's not, because I already did it once this morning. So I'm going to go pretend that I had the enable dialog come up as it did in my picture and enable this dialog. And then I'm going to go back and launch my reader again. So now it's actually a lot smaller. This is kind of my normal indoor font. Right? You build your application today, 12-point font, no problem. Very easy to read. I can sit here all day and read this. Not a problem at all. But now when I go outside, sit on the beach, I can't see anything here. So I'm actually going to take my light sensor, hold it up to these bright lights shining in my face, and you can see how the UI dynamically adjusts to account for that. Right? So the zoom increases, the font size increases. And when you've got glare on your display, this is a lot easier to go and see and go and read than it is when it's like this. Now, if you don't believe me, because there's no glare on the display here, let me show you a picture. There you go. So I went out to the beach and I took pictures of my laptop display with my LightAware UI and without my LightAware UI. And you can see the difference. You know, it's not perfect, but there is a marked difference in readability from the image on the right to the image on the left. Now we've also taken a couple other LightAware concepts incorporated into the right demo. Number one, we've changed the contrast. You notice it's more black and white. It's more contrasty. By doing this, the eye is able to more easily depict differences in contrast, than it is via color. So if you look at the chart, for example, that diagram in the upper right corner, on the left side it's in color. It's really muddied. It's hard to make out the differences between each of the boxes. But on the right, with that high contrast mode, it's a lot easier to go and see what's trying to be presented. So I don't want to get too far down this path. I actually want to show you how I implemented this. This is, after all, a developer conference, and I want to show you the code behind this. So as I said, the MSDN Reader is a sample that's available on MSDN as a download. There's an SDK. We took that SDK, and we changed 3 files. So I'm going to pull up Visual Studio here. And I'm going to switch into full screen mode. There we go. That's full screen mode. So we have 3 files that we changed. First one is Light Sensor Provider. So Light Sensor Provider is a class that interfaces with our shim interop layer. So on these CDs that we're giving out at our booth, we have a sample managed interop code. It's just a sample DLL, very thin layer on our COM API, but it's enough to get the job done. So that's part of this project. And then the Light Sensor Provider is the class that uses that interop layer to enumerate light sensors, figure out what my current light level is, and actually go and store that as a property that other parts of the reader can consume. So first thing I want to show you here is the initialization. So to initialize the sensor, all we do is we create the iSensor Manager object. In this case, it's just a property of this class that gets created on first use. And we call getSensorByType. So earlier I talked about type and category. In this case, we want to enumerate all of the light sensors in the system. So we enumerate all the light sensors into a collection, and then we monitor those. So we add those to our sensor collection. So if I go look at this code, so add sensor collection essentially enumerates all the sensors, prints out some debug messages, and then stores them internally. So here's what we do. When I store it internally, first thing I want to do is just validate that it's a valid sensor. So we're going to do a query. So in my property key set, there's a property key for the sensor friendly name. It's right here. So I said earlier that sensors support properties. It's through an aptly named getProperty method. So we say getProperty, give me the friendly name. You get out a variant. In this case, it's a bster or string. And that's the friendly name for the sensor. So we make sure that it's a valid sensor. We get the friendly name. We print it out. And then assuming that goes well, we register for events. So all we do is set the event sync here. And then we just wait. We wait and we listen and we monitor changes in the ambient light. Sorry, I want to go back up here. So let me show you the event handler. So a couple things we do. First, there's an on-state changed event handler. We don't actually do very much here in the sample code, but you can see some of the different states that a sensor may expose. It could be access denied. If the user hasn't gone into the control panel to enable that sensor, the application won't have access, and they'll get the access denied error. And that's an indicator that you should go and call our enabled dialog to ask the user for permissions. If the sensor is in a ready state or initializing state, that means it's able or very close to being able to produce data. And now when data is updated, we actually have the aptly named onDataUpdated event. And what we get here is we get the sensor for which data was updated. So for example, you can have the same event sync for multiple sensors. So if I have 2 ALS sensors on either corner of my PC, I can enumerate them, subscribe to events, and have them go into the same event sync. And then I get the data report. So the data report over here is the actual light value that's being reported. In order to pull that out of the collection, I need to get my data field. So the data field I use for light value is sensor data type light lux. Again, so I've got my data field, which is light, my value, or my units, which is lux, and the type, which is implicitly defined as a double. So I'm basically going to call into the data report new data and call getSensorValue to figure out our timestamp. We don't want to get a value that's too old. And assuming that that succeeds, we then go ahead and get the actual light value right down here. So a couple other fancy things we do. I'm not going to go through all of it, but the short answer is we take the light value and then we average it out across multiple sensors. Right? So if you have multiple sensors, you don't necessarily want to just pick one. So say you've got 2 on either corner of your laptop screen. Maybe you're standing over here and there's a slight shadow on the one on the left, but the one on the right is really bright. You don't want to just use the value from the one on the left. You want to take both of them and maybe take the median. Make sure you've got a real actual representation of what the current value is. So we do a little bit of that smoothing in here. And then we set a dependent property. So all the way down at the bottom of my class, slide down here, we have our lux value. So this is what's exposed to the rest of the reader application. Whenever the data changes, we take that lux value, we average it out across all the sensors, and we store it in this property. Now through the magic of WPF, that property is bound to a converter, which then takes that lux value and translates that into font size changes. So first thing I want to show you is the XAML. So in the standard reader application, what you actually have here for font size is just a fixed 12-point font. Pretty standard. That's how we design our applications today. We pick a font size, we stick to it. In our modified sample, we change this one line. So the font size is no longer static, but instead it's dynamic. It's bound to the value of that lux value property. So we get the light sensor provider, we take the lux value property, And then we pipe the output of that through our light level to font size converter. Oops, sorry. It's right over here, light level to font size converter. So all this class does, it's fairly straightforward. It takes the light value coming in. It normalizes it. So I said earlier that lux is logarithmic. So we actually take the log of that and try and straighten it out into a value between 0 and 1. Use that as a scaling factor. So we have our minimum bounds, our maximum bounds, and then based on the light level curve, we have some multiplier that we use to determine what the current font size is. And then again, through the magic of WPF, we animate from one transition to the next. So as I go and take out a full screen mode. So as I go and change the light level, it's not a drastic change. So it's actually very smooth, right? So you see we go really small. As I bring it up here and expose it to the light, it slowly grows. I'll zoom in here to an article to show you what the font looks like. I cover this back up. And again, it slowly starts shrinking down. So this is actually very important. It's really important to make sure that the user experience here is optimal. Right? If you just have an on-off switch where you have light aware UI and no light aware UI, that can get really irritating for the user. Right? If stuff just goes from black to white to yellow, green, and colorful, that can get really irritating. If this thing just sits here and jitters, going in and out, in and out, in and out, in and out, that's going to get really irritating. And this does it a little bit. So we want to make sure that when we do build light aware UI, we look at having those smooth transitions. And making sure that we buffer the data value and smooth it out so that it's not a jarring experience. Let me get my clicker back. So here's the C++ equivalent of what I just showed you. Basically, you would enumerate the sensors by type. The request permissions call, this is one thing I didn't show you in the WPF application. This API here is how you invoke that enable dialog. All you do is take the collection of sensors that you want permissions for, you pass it into this call, and you say whether you want it to be synchronous or asynchronous. And then we'll prompt the user to enable all of the sensors you asked for. And if it's successful, then you can start using them immediately. If it's not successful, then typically you'll wait for events indicating that access has been granted. And again, here's a C++ version of what I just showed you in WPF for how we handle the light value in lux. And then we convert that into a scale between 0 and 1. Good. So I touched on a couple of these principles earlier. But what does it mean to build light aware UI? So there are three main aspects that we think about. The first is scale. So obviously, when you have adverse lighting conditions, when you have all that glare on your display, by increasing the zoom level or the font size, it becomes a lot easier to read. So we recommend that. That's what we show off in our MSDN reader sample. But it goes beyond just font size or zoom level. What about the weight of lines? Right? You've got a really thin line separating something. You may want to make that thicker. If you've got a diagram, boxes, you may want to fill those in or make them heavier so that they're more distinguished from the background and from other things around it. That goes along with contrast. So in the picture I showed you a couple slides ago, the one on the right was a much higher contrast version of the one on the left. The more contrast there is in what's being displayed, the easier it is for the eye to actually pick up on those differences. And therefore, the more likely the user is to see it in adverse conditions. Another thing you can do is look at color. So one, increase the color saturation. Again, the more glare on a display, the more washed out it's going to look. So if you increase the color saturation, again, it helps the eye to perceive the colors and the differences between the colors on the display. But not only that, color choice is very important. So you want to pick colors that are complementary. So things that are opposite ends of the color spectrum so they contrast well. You don't want to pick two colors that are near each other, like yellow and green. If you've got yellow text on a green background, and you take that outside, you're not going to see it. Right? You want black on white. You want other colors that are going to be far easier to see, like red on yellow, things where it's distinguished from the background. And finally, as I mentioned, we want to have smooth transitions. We want to make sure that the user experience as the light level is changing is fluid. Right? We don't want it to just jump back and forth between these two extremes, because that's really not improving the experience over what we have today. So I want to summarize sensors. Basically say, what we've got in Windows 7 is a very rich API And it's not limited to light sensors. I don't want to give you that impression. We think light sensors and location sensors are the most common and the most important, but they're not the only ones. The platform is really extensible. We have light sensors. We have accelerometers integrated into this board. I'm going to talk about that in a minute. There are all different types of sensors that can be supported through this platform. And we want your feedback in what ones are most interesting to you as application developers. Which ones do you want to incorporate into your applications to know how the user is using the PC and to make contextually aware applications? Now, in a difference to the location API, the sensor API is about direct access to individual sensors. So we give you that raw access to each sensor, its properties, its metadata, its events, compared to the location API, which is more domain specific. So just also want to say the property keys and the prop variants, we've defined a certain set in the sensors.h file in the Windows SDK. I do encourage you to go take a look and give us feedback about what you think is there, whether anything's missing, whether things that should be added. But I'm not done yet. I saved the best for last. Have any of you guys been out to the big hall down to our booth yet? Picked up our goodies? I imagine that's why a few of you are here. Excellent. So, because this is our public unveiling, we wanted to do something cool for everybody coming to PDC. In addition to getting those hard drives with all the bits, we're giving away our sensor development kits for Windows 7. It comes in this very pretty box, which we designed. And it includes this very pretty green board made by Freescale, one of our partners. On this board, we have an ambient light sensor, which I just used for this MSDN reader demo. We have a 3-axis accelerometer, and we have 8 different touch sensors right down the sides here. It's a USB connected device, and it comes with this wonderful CD of driver code, firmware, full source code for the firmware for this, that MSDN reader app I showed you with full source code, a diagnostic application, some documentation, and the best demo, which I saved for last. So I'm going to switch back over here. And I'm going to run my little marble game. So this is a little XNA application that one of the guys back in Seattle wrote. And it uses a 3-axis accelerometer as input. So it's kind of silly, right? I'm just bouncing a ball around my desktop. But it's pretty cool. And it's also built on XNA. So imagine that you could now use accelerometers and the touch sensors here to go build a game, right? Use this as input. Control your little figure and shoot stuff with the buttons. Or build another way to input into your application using accelerometers. This stuff here, this source code for this application is also included on the CD. And again, this is all managed code. It's XNA, managed code, interop. So for the 80% of you in the room that you thought that I wasn't thinking about you, it's all right here on this disk. So I don't have any here, unfortunately. You have to go down to the big hall to get these. We do have limited quantities, but I am making sure that we'll have some today. And if you can't come by today, we will have a certain number available tomorrow as well. We do expect to make them available online at some point after the event. They're not available right now, but we do hope to have them in the future. So this is really the getting started kit. Take this home with your Windows 7 bits, install it on a PC, plug this in, play with it, write some cool applications. Let us know. What do you think? Does it work well? Do you like it? Are there cool things you can do? We may do some contests in the future. That's more incentive to go pick one up today. And we do have limited quantities. So for all of you in here, you have the sneak peek. You don't need to rush out now to go get it. But trust me, we've got plenty of boxes in the back there. But we don't have enough for everybody. So if you do want one, please go by before you leave PDC. So now that I've hopefully caught your attention, here's how you get started. First thing you want to do, install the Windows SDK. That's where you start with our C++ and COM samples. We also have our documentation, obviously very important if you want to figure out what the APIs look like. But for everybody else in the room, you also want to make sure you pick up this CD to get our WPF samples, our interop layer, and all the stuff that I showed you here today. Now, if you're not able to pick up one of these boards, or if you want to test in a virtual machine, we do have a light simulator in the Windows SDK. Nifty little application. You go run it. We call it a logical sensor. It creates a device node, and it gives you a little slider. And you can drag that slider from pitch black to a really sunny day, and it'll just simulate that light level coming through the sensor API. So you drag that slider, watch the fonts grow and shrink. Hours of enjoyment. So thank you guys for sticking with me here today. Just to summarize, for Windows 7, we want you to utilize the sensor and location platform to build location-aware applications and gadgets. Windows 7 is going to be the easiest platform to build these location-aware gadgets through the Location API. We also want you to integrate with light sensors. We're working with the major hardware manufacturers to incorporate light sensors into PCs. And once they're there, we want you to take advantage of them in your applications to build really compelling user interfaces. But beyond that, beyond location and beyond light, we want you to think about all the cool things you can do knowing the context of where the PC is, how the user is using it, and how the user is using your application, and take advantage of those sensors to build really great experiences. So if you have some time at PDC, I will be down in the big hall. We have a booth where we're showing off the dev kits and some of these demos. We have a hands-on lab over in the hands-on lab area if you want to go learn how to write that location gadget I showed you at the very beginning. We also have a couple white papers which should be included on the hard drive. One of them goes into a lot of detail about how to build light-aware UI. Now, if you want some information after the show, we just launched our WHDC website, where we're linking to our MSDN forum, which also launched yesterday, as well as all the white papers and any additional content that will be relevant to you. So bookmark this link and head there when you want to get any additional information. I'm also available through these email aliases if you've got some business questions. And we do have a brand new MSDN forum for any technical questions. So that's all that I have here today. I do want to encourage you again to fill out your evaluations. I hope you enjoyed the information I had to share with you. And now I've got about 15 minutes to open up for Q&A. Feel free to line up at the microphones. I'm just going to go from side to side until I run out of time, and then I'll be right outside. So thank you again. Appreciate you coming here. Have a good PDC. All right, start on the right.
Is any of this available down level?
No, this is only for Windows 7.
And with the Windows 7 stuff, is location tied into just a sense that the user can define a couple of popular locations, my house, my business, things like that? Does this feed into that such that, or does every app that wants to kind of do something like that going to have to associate location independently?
Yeah, so right now the location is more about the actual location. It's a little less about associating locations with more context. That's more of a future thing. So as you look about what you can build on top of it, now that we have the plumbing to get this data in the first place, then you can start to build the context of, okay, I'm at home, let me do things unique to my home, or I'm at work. And those are the kinds of applications we want to encourage people to start looking at.
Okay, thanks.
Thanks. Go over here. With the other mic on?
Can you hear me now?
There.
Better. A couple of questions. Do we have any future plans to move to the Windows Mobile platform with this?
So this platform is unique to Windows 7 at the moment. I know Windows Mobile does have some support for GPS.
Right. It'd be nice if it was the same on both platforms.
They're not the same right now. Our APIs are C++ and COM, and I think theirs are straight Win32.
Right.
Or
So I guess the other part of this, is this going to be geared at all towards like scientific instrumentation also? Like we have temperature sensors that we want to be able to get scientific quality data. Right now there's, I guess, really not many standards in that area. The old COM ports everywhere, reading serial data.
Mm-hmm.
So is that something Microsoft is going to target and try to convince vendors to start supporting the standard?
It's not something that we're explicitly targeting, but it's certainly enabled and possible with the platform we're providing. Cool.
Thank you.
Go back over here.
Is a camera a sensor?
Is a camera a sensor? Yes. So a camera could very well be a sensor. For example, doing facial recognition, presence detection. Yeah, there are heuristics you can apply to the data you're getting from a camera that could consider it a sensor.
Thank you.
Apple teamed up with Skyhook when they did a lot of their location work. Are you doing anything like that for the Windows platform, or are you simply providing the APIs and no data?
We are working with the relevant partners that provide location data. At this time, I don't have anything I can share, unfortunately.
a lot of my questions have already been answered. One is left. Do you know about any GPS devices that are already available to play with this?
No, not yet. Nothing I can talk about. The one thing I will say, though, is that the existing GPS devices, with the serial port and NMEA, it would be fairly straightforward to write a shim that would take that data and interface it into the platform as a stopgap measure until hardware is available. But there's nothing that I can announce at this time.
Thank you.
Yep. Go over here. Hang on. This is Mike. Go again. Sorry. Is it on?
Test. Thank you. You mentioned the privacy and that the user will have to switch on sensors for the application. And you mentioned that you need administrative rights for that. I mean, an installer has those rights. What keeps an installer from simply switching on all the sensors?
So they can, yeah, if you have an administrator application, I mean, you can switch on all the sensors. The user can go turn them off and disable them. But I'm not sure. Did that answer your question?
Yes.
Okay.
So maybe I just don't know enough about Wi-Fi devices. How do Wi-Fi devices have location built into them that you can then triangulate from? Triangulation I understand, but how?
Yeah. The way that it's typically done today is that you've got vans that drive around and just look at the signal strength and the MAC addresses of hotspots and then record the GPS lat long and send that back to a database. So you just kind of take a snapshot of what location networks, what networks you can see, and send that to a database, and it'll tell you an approximate location.
Okay.
Yeah. Will the your models extend to like external sensors, like typically like Windows, home server, with remote sensors, things like that?
Yeah. So I showed primarily integrated sensors, things like location and light sensors. But the platform really could support anything. It could be a network-connected sensor. It could be a remote sensor, logical sensor. We don't really have any limitations. As long as it can interface with Windows and provide the necessary driver, it can be used by the platform.
Yeah, thank you. The enable API for permission to use the sensor, is it global per the machine, or can you enable on an individual application basis?
It is per machine, so the default opt-in is for everybody on the machine. If you want finer grain control, we have per user control, which can be done through the control panel as I showed. Unfortunately, Windows today only can enforce security boundaries at the user account level. So we didn't want to provide a sense of security that couldn't necessarily be enforced.
Thank you.
Yeah. Any other questions? Great. Well, I'll be here cleaning up if anybody wants to come ask something not on the microphones, and then I'm going to make my way out to the big room. So thank you again. I hope you have a great rest of your time in LA.